So I'm going to be talking about my package Plots.jl. Plots with plots. A picture is worth 1,000 words. In case you want to read a little bit more about me, I'm not going to talk too much about myself, just a tiny bit. You can go to my website or GitHub. Yeah. So this is me. I'm a geek of various sorts. My background is in algorithmic trading for the most part, an MS in math. So academically, my background is in math. But I've been coding on lots of different languages since I was very young. So it's been part of, computers and programming has been part of my life for a long time. And then lately I've been doing kind of self-directed research for myself, for my own company, out of my house in Brooklyn, doing all sorts of learning about and researching, AGI and neuroscience and other related fields, deep learning. And if you want to talk about any of that stuff, come grab me, and I love to have conversations about it.
What is AGI?
Artificial general intelligence. It's the cooler brother of AI.
Scary.
Right. The more generalized version of AI. Skynet, exactly. I actually have a Skynet.jl that's a private package, but so this is what Plots is. It's kind of a lot of things, too many things, some people would say, but the core of it is that it's user-facing, and it's the plotting package that I hope people will start to use in their day-to-day work, day-to-day analysis, and it doesn't do everything, but it's trying to, and slowly more functionality is being implemented in Plots, and not calling down to other outside third-party functionality. And so the kind of the high-level way it works is you give your commands to Plots. It does lots and lots of pre-processing of inputs and attributes. It puts context-aware defaults in for colors and that sort of thing, and it kind of sets it up generically, and then it sends it off to a backend of your choosing. And backends kind of range the gamut from kind of low-level drawing programs like GR, where you can kind of issue more raw commands of draw this, move here, and also things like Plotly, PyPlot, things that are more kind of standard standalone packages that more and more I'm calling into the internals of those packages and bypassing a lot of the interface, but you're still getting kind of the results that you would see if you had sent commands to those. And obviously Plots is not any of those other things that Plots could be, scripts and whatever. Okay, so that's my presentation. I'm done. No. Yeah, so I don't like to talk or write a lot. I like to make pictures. That's why I'm doing this. And it's because I like to visualize everything. Even the most simple little bits of data don't make sense to me until I see a picture of them. And because I couldn't do that already, that's why I kind of started working on this project. So, yeah, if you want to get set up, there's some things that I'm going to be going through that aren't in a tagged release of Plots. So you'll want to check out a master branch of that. And most of what I'm doing is going to use the PyPlot backend, which is probably the best supported of all of them. All of the other ones are pretty close and catching up pretty quickly. And so normally to start, you would just do using Plots and optionally call a backend that you want to use. In this case, the call to pyplot in that second section is unnecessary because it'll choose pyplot as a default backend. But it's good to get in the habit of kind of specifying which backend you would like it to use. And the other package, plot recipes, is a package that's inside the Julia Plots organization that I started. And the idea is that we'll talk about recipes and what they are kind of later on, but it's a holding place for common visualizations that you want to do that aren't core, that maybe not everyone would want to use, but some people might. And so I'm kind of accumulating recipes in this package, plot recipes.
Use any backend with this? So if I use Gadfly, for example, or
well, Gadfly was supported for a little while, and then I made going from 0.6 to 0.7. It was a big rewrite to a lot of the internals, and to be quite honest, there wasn't enough in Gadfly that made me want to work on it. I think I will support it again eventually, but a lot of the code is there that needs to be updated for the most recent version. So what I'm going to do, I'm going to show a visualization of the last 16 years of my life. And so this is using a recipe that's in the plot recipes package. Most of it is kind of setting up this fake data, but you can very quickly see how my time is spent throughout the day. And going from 2003 is when I graduated college, so you can see that there was a lot of video games before that, and not as much work, and a lot of sleep. And as I got married in 2010, I had my first kid. I have 3 kids now. The time for family got bigger and bigger. The time for sleep got much less. So the parents out there will understand this graph very well. But you can see the way it's built. The first section of code there is just setting up our data. We're setting up. We've got a year range that's just defined by an interval, and this percent matrix is just by every year the percentage of time spent. And so in the second section, that portfolio composition, I'll talk about kind of how that works, but that is a plots recipe, and so what it does is it takes in data, input data, and kind of whatever lots of different attributes that can be passed through, and it will build a visualization for you with that recipe. And once it's built, it's just another, like any other plot, and you can add to it, you can change attributes and do different things. And so the second 2 commands, I'm updating with access labels. I'm changing the background color in this case, I changed the background color so that I could have a semi-transparent legend, and I'm changing the y-axis, which uses what I call magic args, the concept being that you can just toss a bunch of related things into the same call, and it kind of knows how to assign values to attributes. But I'll talk about that more later. All right, and so taking the exact same data, you could do lots of different stuff with that data. This is, in this case, I've got a kind of a plot wrapper that's taking several pre-made plots and laying them out in a very specific way. The actual kind of the goal here is to show you that you can do lots of powerful things, and the code that you're writing is only the bare minimum amount of code that you need to specify what you want. And that's, my goal, one of my goals is to make sure that things are so succinct that you can, you only need to say what you want and nothing more. And everything else is kind of figured out for you. So you can see a few different types of, a few different series types and split into different subplots within a layout. All right, so here's another example. I'm going to show you the history of computer languages that I've used over the last 16 years, the same range. Again, I'm making up some estimations of what I've done. I threw this together pretty quickly, so don't quote me here. But basically, I'm creating an input data. I'm calculating an alpha, which you don't have to worry too much about, but I'm going to be assigning different alpha values, different opacities to each series, and a list of annotations that I want to add. Okay, and then these are the calls. They look pretty similar. This one's a little bit more complicated. The idea, so you've got a kind of a base portfolio composition recipe that's being built, very similar to the last one you saw. The only real difference is that you can see the alpha value. I've created my more recent time with Co-Integrated Technologies, which is my company, has a strong alpha. The rest of them kind of fade into the background. And I just wanted to show how you can pretty easily and simply easily control fine-tuned pieces of your visualization and do exactly what you want in very small amounts of code. And so in addition to doing the recipe and setting up the guides, I'm also adding some vertical lines, which you can see. I give a lot of characteristics to those lines in pretty briefly. To make something like this in PyPlot, I probably would have these 3 lines probably would have taken I don't know, 50 or 100. It's just a lot more verbose. Okay, so why do I like Julia? Well, it's easy. I find that it's easier to use than Python. I have to think about things less, and I only need to think about them when I need to think about them. I can go through lots of code, throwaway code as I call it, that I'm throwaway code in that I'm going to do something and it's not going to be part of a library. It's going to be temporary, and I'm going to do something and see the result, and then I'm never going to use that code again. I would say 90% of my code or more is throwaway code, and so being able to write that fast and well is really important to me, and that's one of the reasons I really like Julia. Multiple dispatch is powerful. Plots is driven by multiple dispatch in the sense that I can do lots of very similar things that differ slightly on what types of inputs go in, and this lets me write very small generic pieces of code that can actually do a lot because of one reason is multiple dispatch. Macros, the same thing. We saw very recently this one here, the bottom line. You can see that at layout, which hopefully most of you here at least know what a macro is. And essentially what it's done is taken this definition that looks like an array, and it's processed everything inside of it, and it's generated the code that's necessary to build the internal structure that is this abstract layout.
Is there a specific reason that's a macro, or could it have been done as a function? Why this particular case?
Because I can create my own syntax, basically. So the curly brackets there aren't actually the code that would end up showing up. It's stripping out those curly brackets, looking at the insides, pulling things out, doing something else with them. And that's why I love macros, is because you can create your own syntax within a language. And I do it a lot.
Horizontal macro expand on that?
On that, yeah.
I was just talking about that. So. Can you repeat the questions as well for the video?
Oh yeah, I'll do that next time, sorry. Did I do that right?
You need a parenthesis before the at.
Oh, thanks. Still seem to work.
Can you zoom in? Make the text bigger.
All right. You can see that? So that's what it's a pretty simple layout, and it expands into something that's obviously a little bit more complicated. But it's pretty rare that you would actually need to make these calls yourself. Assuming I've done my job well, that layout macro should cover most of the cases that you actually come across. And so going back to that, so macros are great because you can take things in a really compressed format, kind of have your own syntax and do what you want to, pull things out, swap things out, do whatever you need to, and replace it right in the code base. And so I think that's a really great thing about Julia. And kind of because of all these things, the code is just really clean in the end of it. You have fewer functions to do the same thing, pretty minimal boilerplate code. Or at least you can avoid boilerplate code, and it's just easier to maintain. Okay, so why plots? Why did I work on it? Why should you care about it? So here's what I think a visualization library should be. You should be able to give it any input. Most of the time, if you're just looking at your data, you shouldn't need to set lots of defaults. You should be able to do things quickly and easily, or you should be able to reach in and touch any attribute of the plot and make it look exactly how you want it. And so, I really, sometimes I want to be able to write 10 characters of code and be able to see my data. And other times, I need to have something a little bit more complex, and I really want to spell it out, and I want to make sure that it's reusable for the future. And Plots provides tools for both of those. Okay, and one thing that it should not be, which I would say most plotting packages are, which is frustrating, and I've dealt with a lot of them over the years, but it's kind of the reason I care about this is because I am a visual person. I tend to look at data so much, look at my data structures, look at numeric data, and I'm constantly using it, and I think it changes the way you work if you have the ability to visualize something immediately without having to put thought into how to visualize it. then I think it saves you a lot of work, and it actually changes your workflow so that you can start to, you use visuals as part of your daily workflow as opposed to producing them for a publication, that sort of thing. So I started on plots because I didn't think we had exactly what I wanted. All right, so I'm just going to go through I'll be moving pretty quickly, so if you haven't used plots before, it might be too fast, I'm not sure. But just talk about some of the components and how they're used. Okay, so here's a basic command. It takes in a matrix, 100 by 4 matrix. And one important thing to note here, and you can probably see by the resulting graph, is that plots will split things and split them over columns. So in this case, it's going to create 4 series out of this matrix. And each series can take on its own attributes. I'm setting the palette to blues. Palette is the method of assigning colors to each individual series. I'm setting the shape to auto, which means it can change. So as you add more series to the graph, it's going to give you a new marker shape. I'm setting the marker size to be a 1 by 4 matrix. And again, this is a theme that I'll come back to a lot. In plots, if it's a matrix, then it's sliced over the columns. So if you give it a 1 by 4 matrix, then each item in that matrix is going to apply to one of those series, one of those 4 series. So each series is getting progressively bigger as we go. You can see it in the legend as well. And then I'm assigning an alpha of 0.2. In this case, this is an example of an alias, which I'll talk about later, which alpha is actually series alpha, and series alpha will map to the underlying components, line alpha, fill alpha, marker alpha, and marker stroke alpha. And actually, I take that back, not marker stroke alpha. But concept being you can kind of set it once, and it's going to set it for all of these attributes at the same time. And you have the ability to override any of those as well, and I'll talk about that in a little bit. So here's a very basic example to show a layout and subplots. So the idea here is, again, you have an input matrix, 100 by 4 input matrix that's going to be split among the columns, and setting the layout parameter, similar to as if you use that layout macro and kind of laid them out yourself. This is going to choose, given four subplots, it's going to pick the best grid size in order to fit that, and it's going to create what's called a grid layout for you automatically. And then it will take, kind of assign in a round robin cycling fashion, assign the series to the underlying subplots. So I touched on it briefly, and I'm only going to talk about it briefly here too. But there's lots of different options for what kind of does the final drawing at the end of the plots processing. We've seen PyPlot as a backend, and as a starting backend, that's probably the best one to go to. It's the best supported. Plotly is also really great. It's got really great interactive features, and you can both interact with it. You can interact with it in an iJulia notebook, which is really great. And in addition, Plotly.js, which are 2 separate backends but share a lot of the same code. That package is really cool because it's interactive in an iJulia notebook. It also uses Blink, Blink.jl, to open up a standalone window to view the HTML that is Plotly. And from an iJulia notebook, you can actually update the same, you can have one inlined graphic that gets updated from other cells. So you can have a single place, and you can have additional cells that update the same graph instead of having all of them being produced in their own inline position. So here I'm going to show Unicode plots, which is, as you could make sense, it's something that you can actually just use in the REPL. You don't need to have a standalone GUI window or anything like that. So for people that are, you just really want a lightweight solution, or maybe you're doing some analysis on a remote server, something like that, this could be a really good option. And so I just, quick demo of how you do that. You change the backend, and then the plotting command will just flow through to Unicode plots instead. So slightly unlike some other packages, a plot object is just like any other Julia object. The internals are being changed as you're applying transformations and calling plotting commands, and it's not actually displayed or written anywhere until you it is returned to either the REPL or an iJulia cell, or if you explicitly call display. And actually, there's a fourth option. If you pass a show equals true into a plotting command, then it'll also call display at the end of the command. And at the bottom there, there's a lot of different ways to do the same thing, which is all of these will produce a PNG file as output. And, I think it highlights one thing that not everyone agrees is the best, but I think it is. I think there should be many, many ways to do the exact same thing, because there's lots of people in the world with differing opinions and different workloads, and sometimes you want to do it one way, and if that's not available to you, that sucks. So I believe that there should be, especially an interactive analysis type of environment and workflow, there should be lots of ways to do the same thing so that anything you try works. Okay, I'm going to talk a little bit about attributes, which is kind of the look and feel of the visualization. So I said briefly before, aliases. It's effectively, there's lots of different names that you could call your attributes. Color, for example, is really series color, but you could also call that C. And there's a bunch of other ones, and if you go on the docs and the attributes section, I've got some tables that kind of lay out what the attribute name is, but also a list of all of the aliases that you could call it. For those cases where you don't want to look at the documentation and figure out what the right command is, just try something, and very frequently it'll work. And it's because there's so many ways to do the same thing. And so you can see a comparative example here. C equals red is the same as series color equals red. MS equals 10 is the same as marker size equals 10. And even some of the values have aliases. You can see at the end, y scale equals log. Well, that's the same as y scale equals log 10. And so, the theme here is that hopefully you'll just try things out and well, I take that back. You should go read the documentation once, and then hopefully you don't have to look at it too much after that. And so magic args, as I've been referring to them, are a similar kind of concept, but you take you pass a bunch of attributes into kind of a special argument, which is going to process the full list of things that you're the full list of attributes that you pass in, look at their types and try to do matching based on the types of what attribute it thinks that you mean. So in the case of comparing, these are equivalent commands. These, the plot with everything spelled out explicitly, and the bottom one uses these magic args. So the line attribute can take a list in any order. These, it doesn't need to be ordered in a special way. Just toss values in, and it's going to look at the values, look at the types, and sometimes look at the values as well. And it's going to figure out that the 3 should be applied to line width, and the 0.5 should be applied to alpha. The blue should be the color, and dot should be the style. And you can do the same thing for marker, for fill, and the axes as well.
How does it tell line width and alpha?
Sorry?
How does it determine the difference between a line width and an alpha?
So in that specific case, if I believe the logic is if it's an integer that it's line width, or if it's not between 0 and 1. So 2.5 would be line width, 0.5 would be an alpha. And that covers most scenarios, and then if you hit a scenario where it's doing the wrong thing, you could just explicitly say it. But I've done a lot of plots, and it's very rare that it does the thing it does something that you weren't intending. Okay, so I've said this 1 or 2 times already, and it's this concept that matrices in plots are sliced by columns. Not always. There are cases if you're doing a surface plot, for example, it's going to see the context that you're trying to do a surface plot and is not going to slice it up. But in a lot of cases, it's going to take a 100 by 4 matrix, and it's going to assume you want 4 series. And the same for attributes. It's going to do the same kind of a thing. So you're going to apply each column of a matrix to a series, or in the case of a subplot attribute, you would take a column of 4, or 4 column matrix, and apply it to 4 subplots. And so you can see an example of right and wrong here. The label on the first one I've passed in as a matrix. I've got spaces between the A, B, C, D. And when I plot that's on the left, you can see the A, B, C, D gets assigned, mapped or assigned to each individual series. The second example, I've passed in a vector. So I've separated by commas. So it's a 4 by 1 matrix equivalently, and so that column gets mapped to every single series. So when you look at the label, you can see that the whole vector ABCD applies to each one of those series in the series label. And it's when you're first starting to use it, that's probably the biggest stumbling block is why is everything getting this vector? And so if you can remember this is one of those things where just commit it to memory, and you're good to go after that. And I should say the underlying reason why this happens is because there are so many ways to do so many different things. There has to be a way to separate it out, and to make sure that you can distinguish one scenario versus another. And so I made the decision fairly early on that the most common scenario is that you would want to split that way, and I didn't want to limit the ability to pass in. To do in the second example, there are many times where you might want to pass a vector to every single series, and if I allowed a vector to map to all the series, then I'm taking away functionality, and I didn't want to do that. I wanted to make sure that that you could have a vector be mapped to every series. So I made the decision early on that this is worth the price. So cycling, if there's not enough values, they're repeated. And here's an example of that. So the color, it's going to see in that marker argument that the red-blue matrix there is intended for marker color. And it's going to then map red to the first and third, and it's going to map blue to the second and the fourth series. And so you can see that happen right there. Okay, just to talk briefly about the different types of series that you can make. I distinguish these from visualizations because you can combine many different series on the same graph, and you can overlay them. And there's a lot of power with that. A lot of packages will, let you make a 2D histogram, say, but then it's a special plot type, and you can't really do very much with it. You can only view it this certain way. Well, I don't like that. I wanna be able to throw scatter plots on top of it and make annotations in a nice way and do it generically. And so everything flows through the same plotting pipeline. And so you can layer different types of visualizations on top of each other. So, this also kind of shows you a couple of things. This is a sampling of series types in 2D that you can make, and they're all using. You can see the second line is plot randen 21. So it's one series that's being mapped for each of these series types. And I'm setting the layout to be just the length of that S-types vector. And that's about it. The rest of it is just setting up some visuals, taking away the tick marks, taking away the legend, setting the size of the graph. But you can see how, in some sense, each one of these series types is not that different from one another. It's just how it's eventually displayed or visualized. And you could have just as easily not had that layout command, and you could have layered these on top of each other, or whatever you want to do. So 3D series types, here's just a sampling. Very similar concept to the last page. I'm creating an x and a y and a function that takes in x and y and maps to a z value. And so I've got a list of series types, and I'm just going to create a 2x2 grid mapping the same data, the x and y plus a function, and mapping that and creating a subplot for each series type. Hopefully you can see that this code is pretty compact. There's not a lot in there except what you're actually trying to do, and that's a recurring theme as much as possible. So talk briefly about layouts. Some simple, some complex, and then talk about floating or inset subplots. Just checking the time. The simplest layouts are grid layouts, and you've already seen a few examples of those. And so you can create one with this the grid function, which is really just calls through to the constructor of a grid layout. And it takes a number of rows, number of columns, and you can also, you've got optional parameters to pass in width and heights of the grid. And here's an example of that. So I'm explicitly creating a grid layout and passing in a list of widths for each column of the layout. And for those of you that have used other plotting packages, usually something like this would be pretty hard to do, or if not hard, annoying. And so one thing to take note of is that the layout percentages are based on the plot area, not on the surrounding subplot. So I don't have a good slide for this, but my terminology, you've got the full plot. A subplot includes the title of the subplot and the guides and the ticks. The plot area has the border and the grid inside of it and the actual data. So if one of those subplots, say, had really long tick labels, it kind of gets shoved off to the side. Many plotting packages would have these weird misshapen, plot areas that don't seem to match with the layout that you wanted. But here it'll shift accordingly and resize all of the plot areas to match. All right, so we already saw an example of the layout macro, but it's important to note that it's it's a nested structure that you can make, and so you can have kind of arbitrarily complex trees of layouts, and you can create them all from one layout macro. And so here's a quick example of that, making kind of a complex structure, and in the middle right section, I'm actually creating a 2x2 grid, which I'm instantiating directly. And so you can kind of get a feel for how complex that can be. And I've only set a couple of sizes. I've set a width on A and a height on C, and everything has been calculated to conform to those sizes. And here's an example, because one additional thing the layout macro will do is it populates a mapping, a dictionary of the name that you give it for each subplot to the actual subplot object. So if you wanted to, you can actually reach in with the accessing the plot object.sp map. You can reach in and get to the underlying subplot and make changes or do whatever you need to. And I think over time, it'll be easier to act on individual subplots rather than the entire plot itself. That's something that's ongoing, but it's already pretty usable. And this is a fairly recent addition, being able to put plots within plots, not plots with plots, plots within plots. And here's an example of that. So I've added the inset equals, which is actually an alias for inset subplots. And in this case, I'm just doing one, but you could also pass a vector of these mappings. And so that at the very bottom, that inset equals, I'm saying I want the parent of this subplot to be the first subplot, which is subplot A. Sorry. And this is the relative bounding box that I want the plot area to be in. So I'm saying that I want the right side to be the anchor point. And so my XY value is going to be the top right of the plot area of subplot A, and then I'm going to initialize it at 0, 0 at the origin, top right, and I'm going to make it 60% of the width and 200 pixels high. And you can mix and match and do different types of algebra on those coordinates.
Can you do the algebra reaching out to meet the stuff from one to the other, from subplot A to subplot B, or is the algebra limited to subplot within subplot A and within subplot B?
So I'm not sure if this is going to answer your question. Why don't you ask it one more time so I understand?
I think this is really powerful, neat, and tight. You mentioned that in addition to saying 200 pixels, you can create values algebraic through algebraic relations with other values. The question is, here you have two disparate plots, but for some reason they're on the same page because it's meaningful, whatever.
Right.
And so can you take, say, the line width that you're using in subplot A and use that as an algebraic entity to determine the pixel height in subplot B?
I mean, not automatically. Certainly, you could do that. There's no stopping you from making that calculation yourself.
Right. As long as that's really my question. I can write it in there somewhere. And
Yeah, I mean, it's just you could write any valid Julia expression. That px. This is, you can see that inset equals. That's not a macro. That is, you're passing in values. The px is actually a constant value. Uses measures.jl, which underlies compose.jl, and lets you combine absolute units and relative units, and they're basically stored until you actually need to resolve it later on. So 200 px is actually is actually 200 times the constant px. So you could do whatever you wanted. This is not a custom syntax.
I'm trying to follow along in your example here, and I'm getting an error. I just updated your package. I'm getting an error in the box saying that it's going to have a signature that matches in 64 and 64, split 64, a measurement's length, and a symbol. Is that something that's not expected to work on the current version?
You checked out the master?
I didn't check it out. I just use the package manager. Is that the problem here?
Okay, yeah, probably. I've probably got 10 to 12 commits since the last tagged release, and yeah, I think that signature is probably only valid with one of those commits. I'm really bad with tagging with tagging versions. I tend to do it like once a month and do it all at once. So we're going to move on to recipes, which I think are the really cool part about what Plots has become. So in a nutshell, what recipes are is they take they take some sort of input data and attributes that are associated to that data, and they transform it into something else. And so an example of a recipe is a recipe for a histogram. You take in a vector of values that are sampled from a normal distribution, and that's your input into a histogram. And the recipe of the histogram is actually going to take that data, bin it, look at the frequency counts, possibly normalize them, possibly use different weights for each data point, and it's going to produce an input to the next layer, which is the edges of the histogram and the heights, and potentially there's some other attributes that you might want to set along the way. And so that's an example of a recipe where you're converting one thing, maybe applying transformation of some sort, maybe you're changing the attributes that apply to it, and then you're outputting the result. And so what's great about recipes is that you don't have to think about the plotting or anything else really. You're just thinking about that transformation. You start thinking about everything in terms of transformations, and you can mix and match them, and it can become a modular structure where you can reuse this in here, here, and here, and you don't have to repeat your code all over the place. And beyond that, it's conceptually easier to think about this one change from this into this. And so recipes are kind of core. It's actually very similar to the way Julia works in the sense that a lot of the internals of Julia are built with Julia. And it's the same, the reasoning why that's good is the same kind of concept where things are reusable and composable in such a nice way that it actually, it makes the whole system easy to understand and maintain. And things that a user makes are first-class citizens. There's nothing special about what was built into a library versus what a user adds to the library in their REPL. So here is an example recipe. I've got it wrapped with printing a macro expand, but you can kind of ignore that when you first look at it. And so what I'm doing is I've got a valid Julia function, and I'm putting at recipe at the beginning of that. The idea here is I've got an attribute that I'm going to set to 20, and then another attribute that I'm going to optionally set to blue, and I'm going to return v, our input value. This doesn't mean anything. I'm just trying to demonstrate what a recipe does under the hood. So if you look at the expanded version of that, the first important thing to note is there's this mythical object D, which is a dictionary it's our attribute dictionary that kind of gets inserted at the beginning of that. So with every recipe function that you make, there's always going to be this D dictionary that holds all of your attributes. And in some sense, the two things you're doing, you're updating this attribute dictionary D with whatever changes you want to make to it, and you're returning the transformed inputs. So in this case, I didn't actually transform V in any way. I'm just going to return it the same way it came in. If you look at the actual expansion, kind of in the middle of the expansion, you can actually see the code block that gets translated. You can see that D of attribute 1 is 20, and instead of the same thing for attribute 2, we're doing this get exclamation point, which basically says if it's in D, then keep it. If it's not in D, then set it to blue. And so going back to making my own syntax, it's just a couple of shorthands to be able to set attributes in a clean way, so I don't have D colon whatever peppered all over the place. And so what this is building under the hood, you can see at the bottom is it's a list of these recipe data structs, and each recipe data has an attribute dictionary, and the data, a tuple of the data that's going to be passed through. And so, as you'll see as you start playing with these, you can create many recipe data objects, and you do that with the series macro that I think I'll have an example of that. I'm not sure, but the idea is that you could take in your histogram and create 3 different series, for example, that show different aspects of it, and so you can be expansive and add a lot more than just a simple transformation. You can actually do a lot more than that. Okay, I'm not going to go through the details of this code. Kind of in the middle here, this graph plot, this still needs a lot of work, but this is a recipe that's in plot recipes, the package. And the idea is that you can pass it an adjacency matrix of a graph with nodes and edges, and optionally a function of how to lay out that graph on the screen. I've got one version implemented that's a spectral layout that you can go to that package to look at it if you want. I won't talk about it here. And then all of these attributes that I'm passing in are kind of flow through the recipe infrastructure and get picked up by any recipes that care about them, and eventually they end up at the plotting layer. And so what I'm doing here is I'm just looping through these these types, and I'm creating a new inset plot. So I didn't want to cheat and actually make these graphics myself. I wanted to make everything with plots. So I'm creating inset plots on the nodes where the nodes of the graph are. So this is the lines you can see are represent the graph plot, and then I've made inset plots on top of them with titles to kind of show the tree-like structure of how these recipes are applied. So this marginal hist, which I will show you later, is actually decomposed into into a histogram and a 2D histogram, and each of those are then recipes for something else. So a histogram 2D is a recipe for a heat map, and a histogram is a recipe for a bar plot, and a bar plot in turn is just a recipe to make a bunch of shapes. And so one of the great things about this switch to recipes is that I've been able to comment out over half of my backend code because I no longer need to support most of these things. I can just let the recipes pass it through to a shape and let PyPlot draw a shape. And PyPlot is just drawing all these shapes as it needs. And so in terms of the individual backends, they can choose to either support a series type natively or to have it flow through to something that's a little bit more low level. And it's enabled like the GR backend, for example, to be almost fully featureful with PyPlot, even though it's very low level. Yeah?
Question, in the plot bang call, what is being mutated?
So this has been a question in the past, which I can see both sides of it. What's being mutated is an invisible plot object that's put in there as a convenience. So the actual command is plot bang the plot object that you're mutating, and then the rest of the inputs and the keywords. It just so happens if you leave that plot object out, there's a global current plot object that's going to be thrown in there. Hopefully, I think people disagree on whether that's kosher. I won't say that it definitely is, but it's good enough for me.
You can still use the plot object in there everywhere else, right?
Yeah, you can add your own plot object. It doesn't have to be the most recent one. It's just people are happy to have it automatically inserted and not have to track the object themselves. I know I am. So in order to just keep it consistent, it's easier to do it this way. Okay, so there's lots of different kinds of recipes, and they get processed at different points of the plotting pipeline. User recipes are very early in the pipeline, and they'll take in essentially raw inputs. The only thing that's happened before you get to a user recipe, or before a user recipe is called, is that the arguments are pre-processed. So things like the line equals, where you can shove a bunch of attributes into one command, that'll be pre-processed into line color and those sorts of things, and aliases will be applied. But those are very simple pre-processing steps. So when it gets to a user recipe, there's a good chance that it's going to see what the user what you actually inputted as input data. So just as an example of when you might use a user recipe, you've got a custom type, in this case a distribution, and so the idea here is you call plot on a distribution object with an optional x range, and then whatever attributes that might apply to the underlying plot that's going to be made. And I'm just doing a simple mapping of x to some function which defaults to PDF of the distribution. I'm mapping that over the x range, and I'm changing the series type to be path. And so it's going to create a path with x and y as the new inputs to the next layer. So this is making this recipe is the same as if, or very similar to as if you did those transformations yourself. If you mapped out a PDF of a distribution to a y value and passed in your x range, except that here where I can set, I have this default range function, which is going to look at the, try to give it a sensible bound using the mean and standard deviation of the distribution that you pass in. So you can do like convenient, nice things in your recipes that might be a little annoying if you did them every single time. But you can see here in the final plot command that you still have all the conveniences of being able to add fill to a graph and that sort of thing. So kind of gained a lot of functionality. We can plot any distribution and give it whatever attributes and that sort of thing.
This is not using the default, right? Your plot over here.
This is not using the default range, which the way I have it set up is appropriate for normal distribution, but not for a gamma distribution because it would go off to the left side. It'd be too wide on the left side.
You get the recipe that's function f just because you said recipe's function f before plotting? It's applied just because you said so earlier?
Right. So the question being, how does it get inserted into the pipeline, or how do you?
Yes, and how do I uninsert? If I've gotten some recipes, made pictures I want to make more pictures that don't use some of those recipes, can you go look later?
Well,
Really, Tom,
this is a question for you. Yeah, can you? Is all that's happening is it's adding a definition to recipes-based.apply recipe. So you've got a method the same way that you might add a definition of plus to base.plus. You're adding a new definition with your input types and letting multiple dispatch do the work of figuring out what gets mapped to what. So you could override that definition with a new one. You could redefine a recipe with the same input signature, and it would override what's already there, the same way as any other function. If you had two different type signatures going into a function, it would if one exists already, it would be overwritten.
So just so I'm clear, this recipe is being applied because it takes a distribution as its first argument and we're calling plot with the distribution.
Right, exactly. So.
So the answer to that question then is that it depends upon being able to remove a method from a given function,
Yeah, I'm actually not sure how you would do that. I'm sure someone knows, and I'm sure it's possible, but but yeah, it's just being added to a method. So it's just a Julia method. The recipe macro itself is just to generate all of that code that surrounds it in order to create the list of recipe data objects that are going to be mapped out. And
Simple terms, all the recipe is doing is you're giving it a function and it puts a boilerplate around it to generate your plot that's as full featured as any other plot you would do with your own.
well, in generating the what would be the inputs to another plot, yeah. And so one thing to note, the way I made this recipe is you can see I used the dash arrow, which is an optional override. So if you wanted to set your series type to something else, you could actually have your distribution data be applied to a different series type.
Quick question.
Yeah.
If you wanted to plot like the CDF or something, is the func keyword now available through the plot command, or how do you change that keyword?
Right. So you would say func equals CDF as part of your plot command, and the recipe would kind of gobble it up, use it, and you can see the first line here. Eventually, I think you won't have to do this, but right now you would have to pull that out of your attribute dictionary. What it does is it takes all of the keyword arguments and shoves them into your attribute dictionary, so you can get to them whenever you need to. Okay, so that was a user recipe, and part of what makes it a user recipe is just the dispatch signature. You've got a unique signature that if your inputs match the dispatch signature, it's going to hit as a user recipe early on. There's something else called a type recipe, which during the processing, I should add real quickly that all the recipe processing is recursive, in that if you apply a recipe, you can create something else that's going to be the input to another recipe. So you can have it just keep processing until it doesn't find anything else to process. So you can have layered recipes. So as part of this, a type recipe is when you have a user type, a data type that is really just something else. So in the case, I give the example of SymPy, where basically a SymPy variable can just be converted to a function. And you can call this lambdafy method on a SymPy variable, and it will give you a function back. And so, usually the way it was written in the past is there was a 500 line file that had lots of plotting routines and that sort of thing, and it was really all just different ways to convert SymPy variables into functions so that you could analyze and view them. But with a type recipe, you set up your type recipe, and anytime you encounter an object of your type passed into a plotting function, it's just going to convert it for you. So it opens up every combination. You can, any place that a function in this case is valid in plots, then you could also pass in a type recipe. And again, this is the only reason it gets to the type recipe is because of the signature. You need it to be type of the same type. First you put in : type of t, where t is the same type as your object that you're passing in. And so it's also being added to the same function, this recipes-based dot apply recipe. And so what it does is if you create something that has exactly that signature, that when it's looking for replacements to be made, it's going to come across that, and that's multiple dispatch, kind of making life very nice and clean and easy. And here's a short example just showing how that would work. So you can see I've created a fake wrapper type that wraps an object V, and I'm creating a type. Actually, no, I did this example wrong. It still worked. I think I hit a different part of the, yeah, there's a mistake. I meant to show off type recipes and I made a user recipe. It still worked, so I didn't even notice. That's the essence of plots though, right? You do something and it works exactly the way you wanted it to, even though you didn't do it right. So what I meant to do was have the type signature out here, and it would have hit a different part of the code, but it would have done the exact same thing. And the idea, again, is that you pass this in. You don't need to worry about all the different combinations of things, of a vector and a matrix and a function, and maybe you've got a function and two numbers to create this is the range of function values that you want to map to. You don't need to think about every single combination of things you could possibly plot. You just know that you think about only what you need to think about, which is this is really the same as this. Okay, so this plot recipes is new since the last tagged release, and they're very similar to to series recipes. They're just processed at a slightly earlier time to them. And so the idea being that just after all of the user recipes and type recipes have been processed, but before the plot itself has been built, the layout of the plot has been built, you can get you can trigger a plot recipe which can actually build a layout for you. The good example is marginal histograms, and this is implemented in plot recipes. And so this is a 2x2 grid where the top right corner has it's called an empty plot, an empty layout, and you've got a 2D histogram with a histogram or a density plot, and so you can see you're able to kind of tap in and change the whole structure and layout of the resulting plot from within a recipe. If you go to Plots.jl, you can see the code right there. It's pretty easy to find, I think. But the idea being that you could pass a function and other things, and your input and attribute processing is separate from that. Conceptually, you only need to think about, well, I want to make this layout and I want these series types to be in each subplot, and that's all you need to think about. Everything else is kind of handled outside of that. And the last one is series recipe, and these are called kind of at the very end of all the processing. The layouts have been built, the subplots have been defined. And also default values for all the attributes have been filled in. So this is, you've almost got like a ready-made description of your plot, and now you want to add your data into it. And so an example recipe here is a box plot. So a box plot is just a bunch of shapes and a scatter plot thrown in. And so this is in, I should have put the code up there, but if you go to Plots.jl in the source directory /recipes.jl, you can find the underlying code for these just to see what they look like if you wanted. But the concept is you're taking in your data. In this case, I'm taking in a data frame and symbols representing the columns, which data frame support is completely done by recipes. In this case, data frames are processed as user recipes. And so that just gets mapped out to the respective data columns, and that gets turned into shapes and scatters, as you can see. Do I have 10 minutes? Is that right? Does anyone know?
Yeah.
10? Yeah. All right. Wonder. I was going to try. Yeah, I'm going to skip the live coding thing that I was going to do. I think it's going to take too long. All right, so future development. I think there are aspects of the recipe flow that can be made better and more robust. I think the plot recipe and series recipe can maybe be combined together a little bit better. I think updating plots could be a little bit nicer. There's certain things that and there's open issues for a lot of this stuff. And so if you want to go to plots and look at the issues, you can kind of get a feel for where it's heading and what still needs to be filled in. If anyone wants to contribute, please do that. I think one aspect that could use some work is performance optimizations. I haven't really been thinking about the performance of plots too much, partly because plots is not involved with the underlying drawing command, so it doesn't matter quite as much. It's a fixed overhead for a lot of this stuff. It doesn't really matter if you've got a billion data points. But there are aspects that I think could be improved and optimized. And also, I think for the workflows where you've got a plot that you're pushing data into, time series plot that's being added to consecutively, I would like that stuff. Right now, it doesn't touch the recipe side of things, which I think is too bad. I would really like to be able to push data into a histogram plot and have that update the histogram as you go. That's not connected, but I think it will be eventually. I was talking to Simon about GL Visualize. I think there's a 3D backend that could be really cool to add. And I have fingers crossed that by the end of JuliaCon we'll have GL Visualize support, and then just kind of building out the portfolio of recipes that you can draw upon, so that packages like ggplot2 and others seem like they don't have that many features. And so that's, I'll leave some time for questions, and that's my presentation.
So this seems really, really good, especially for like someone who's a data scientist or just wants to see their data quickly and easily. Do you find that if you want to take it to the next level, like really production quality graphics and things like that, that ultimately...
Do you mean like publication quality graphics?
Yeah. I'm just like wondering, like if you go back to very early on, you had 4 histograms.
Yep.
Okay, and like one of the tweaks that I might have wanted to make to them is to have all of their y-axes be the same. Without specifying what they are, I just like to specify that they're the same.
Link equals all. Done.
It's that easy, huh?
Yeah, done. The idea is that it can be used for any type of workflow that you would want. And speaking about publication quality, publication quality graphs, PGF plots, which is based on, it's got a latex backend, is one of the supported backends that's kind of, I would say it's 60 to 70% supported right now. But over the next month should be fully supported. And so that is, publication quality. And when I'm choosing what backends to support, it's kind of like, do they fill a gap that other backends don't? And so it got a nice blend of different types. Plotly for web animations, and actually I didn't even touch animations at all. Go to the plots documentation, look at animations. You can do some really cool stuff with that. But yeah, the idea is that you would be able to do as intense of a workflow as you'd like to do, but you could still do interactive work just as well. Yep.
Is it integrated with Juno?
So actually, sort of and maybe. I was trying Atom for a little while, and I got about half the backends working in the plot pane there, and then nothing against Juno. I think it's and Atom. I think it's really great, but I was having performance issues. For my workflow, I think I was probably keeping windows open too long and whatever it was, and I decided to switch back for a little while until things are a little more stable. But that being said, so I haven't been able to test that workflow in a little while. So I know some people do it, but it might be slightly buggy. It's one of those things that that you can try and see if it works, and I can help where I can. Go ahead.
How do you test this?
Good question. Actually, that's I would say this is probably better tested than most libraries out there. I have a package called Visual Regression Tests that uses an algorithm that Tim Holy helped me with. And the gist is that it is able to compare two images that were produced. So a reference image that I've already validated, and an image that's produced kind of on the fly, and do a fuzzy comparison where it says, is this essentially the same image, or is there something off about it? And I found it's really actually pretty great because it can pick out. So if say the marker color isn't being set properly, there's enough of a difference between that and the reference image because of the marker colors that it flags it as being an error. And so what happens is frequently Plots will be failing its builds, but that's just because it's such an extensive integrated test suite. And I test lots of different types of plots and lots of different attributes to each of the plots, and I compare them against reference images. And that's all run automatically on Travis with every single push.
That's a lot more thorough of an answer than I was expecting. Are you able to use that to compare with different backends, or are the images sufficiently different when you switch backends that you can't use a reference from one backend to compare, a live copy from another?
Yeah, I think it would be cool if they were so similar that would actually work, but I think. I don't think that's ever going to be true. I compare PyPlot backend images to PyPlot backend images. Though I do strive, when possible, to keep the output as similar as I can between different backends. It's not practical for it to be exactly the same in the way that it's checking.
I like how you've done the animations package. Is it possible to get those GIFs to play back in iJulia? I've noticed you can render them to GIFs.
Yeah, it's the return value from the cell. It automatically opens in iJulia.
Yeah, so maybe there's
It didn't work for you. Okay. Did you use the at GIF? Yeah. Okay. Open an issue, please. Yeah. If you come across anything, open issues. I'm usually pretty good at responding and either pointing you in the right direction, or maybe it's a bug that I need to look into. There's a pretty complex piece of software that I can't see everything that comes up. So it's very helpful if you open issues when you find things. No? Okay. Thank you.